HVAC interview questions with detailed answers. What is local comfort cooling system? A local comfort cooling system is a type of air conditioning system that is designed to provide cooling and dehumidification to a specific area or room, rather than an entire building. These systems are typically smaller and less complex than central air conditioning systems and are commonly used in residential and small commercial settings. Local comfort cooling systems are often installed in individual rooms or spaces, such as bedrooms, living rooms, and offices, and are designed to cool only that particular area. They can be mounted on walls, ceilings, or floors, and are available in a variety of styles, including split systems, window units, and portable units. These systems work by drawing warm air from the room through an evaporator coil, which removes heat and moisture from the air. The cooled and dehumidified air is then circulated back into the room through a fan. The heat and moisture that was removed from the air is typically expelled outside the room through a separate unit or duct. Local comfort cooling systems offer several benefits, including energy efficiency, cost-effectiveness, and ease of installation. Because they only cool a specific area, they can be more energy efficient than central air conditioning systems, which can cool an entire building even if only one room needs it. They can also be less expensive to purchase and install than central systems, and they do not require extensive ductwork. What is a centralized air system? A centralized air system, also known as a central air conditioning system, is a type of air conditioning system that is designed to cool an entire building or home from a central location. These systems are typically used in larger commercial and residential settings, such as office buildings, shopping centers, and multi-story homes. A centralized air system consists of a large compressor unit that is typically located outside the building or on the roof, and a network of ducts and vents that distribute cooled air throughout the building. The compressor unit draws in warm air from the building through the ducts and vents, which is then cooled by passing over an evaporator coil. The cooled air is then distributed back into the building through the network of ducts and vents. Centralized air systems can be configured in a variety of ways, depending on the specific needs of the building or home. They can be designed to provide heating as well as cooling, and can be controlled by a thermostat that allows users to set the desired temperature for the entire building. While centralized air systems offer many benefits, including the ability to cool an entire building efficiently and effectively, they can be expensive to install and maintain. Additionally, they can be less energy efficient than local comfort cooling systems, particularly in situations where only a portion of the building needs to be cooled. What is constant air volume, (CAV)? Constant air volume, (CAV), is a type of heating, ventilation, and air conditioning (HVAC) system that delivers a fixed amount of conditioned air to a space or room regardless of the heating or cooling needs of that space. In a CAV system, the air supply fan is designed to maintain a constant airflow rate, while the temperature and humidity of the conditioned air may vary based on the heating or cooling requirements of the space. In a CAV system, the amount of conditioned air supplied to each space is typically determined based on the maximum cooling or heating load of that space. This means that even when the space is not at maximum load, the same amount of air is supplied to the space. The system relies on other mechanisms, such as thermostats or dampers, to regulate the temperature and humidity of the supplied air. Constant air volume systems are commonly used in large commercial and industrial buildings, such as office buildings, hospitals, and hotels, where a consistent and predictable airflow rate is required. They are often less expensive to install and operate than other types of HVAC systems, such as variable air volume (VAV) systems, which adjust the amount of airflow based on the heating or cooling needs of each space. However, constant air volume systems may not be as energy efficient as VAV systems, particularly in buildings with varying occupancy levels. or uneven heating and cooling loads. In addition, Hvac systems may result in temperature and humidity fluctuations in spaces that are not at maximum load, which can lead to discomfort for occupants. What is variable air volume, VAV? Variable air volume, VAV, is a type of heating, ventilation, and air conditioning, HVAC, system that delivers varying amounts of conditioned air to different areas or rooms within a building, based on the heating or cooling needs of each space. In a VAV system, the air supply fan is designed to vary the volume of air supplied to each zone or space, while maintaining a constant temperature and humidity level in the conditioned air. In a VAV system, the amount of conditioned air supplied to each space is determined by the heating or cooling requirements of that space, which are determined by factors such as the occupancy level, the number of windows, and the orientation of the space. VAV systems typically use a combination of thermostats and dampers to regulate the airflow and temperature of the supplied air. VAV systems are commonly used in large commercial and industrial buildings, such as office buildings, hospitals, and hotels, where different areas or zones within the building may have varying heating and cooling needs at different times. VAV systems are often more energy efficient than constant air volume, CAV, systems, as they can adjust the amount of airflow based on the heating or cooling needs of each space. However, VAV systems may be more expensive to install and maintain than CAV systems, due to the additional complexity of the system and the need for more sensors and controls. Additionally, VAV systems may be less effective in spaces with very high or very low heating or cooling loads, as they may not be able to maintain a constant temperature in these spaces. How vapor compression cycle works. The vapor compression cycle is the most common type of refrigeration and air conditioning cycle, used in many types of cooling and heating applications. The cycle works by transferring heat from a cooler environment to a warmer environment, using a refrigerant as the working fluid. The vapor compression cycle consists of four main components: a compressor, a condenser, an expansion valve, and an evaporator. Compression. The refrigerant enters the compressor as a low-pressure, low-temperature gas and is compressed to a high-pressure, high-temperature gas. The compression raises the temperature of the refrigerant and increases its pressure. Condensation. The high-pressure, high-temperature refrigerant gas then enters the condenser, where it releases heat to the surroundings and condenses into a high-pressure, high-temperature liquid. Expansion. the high-pressure, high-temperature liquid refrigerant. Then passes through an expansion valve, where its pressure is reduced, and its temperature drops rapidly, creating a low-pressure, low-temperature liquid refrigerant. Evaporation. The low-pressure, low-temperature liquid refrigerant then enters the evaporator, where it absorbs heat from the surroundings and evaporates into a low-pressure, low-temperature gas. The heat absorbed by the refrigerant is transferred from the surrounding environment, resulting in a cooling effect. The cycle then repeats, as the low-pressure, low-temperature gas refrigerant is drawn back into the compressor to start the process over again. Overall, the vapor compression cycle is an efficient way to transfer heat from a cooler environment to a warmer environment, using a working fluid. This cycle is used in a wide range of applications, including refrigeration, air conditioning, and heat pump systems. What is heat load and how it is calculated? Heat load refers to the amount of heat that needs to be removed from a space or area in order to maintain a comfortable and safe environment. This heat load is generated by various factors such as people, lighting, equipment, and solar radiation. Accurately calculating the heat load is essential for designing and selecting the appropriate heating, ventilation, and air conditioning (HVAC) system for a space. Heat load can be calculated using various methods, including manual calculation. This method involves using a set of equations and data to calculate the heat load of space. The equations take into account factors such as the size of the space, the number of people, the amount of lighting, and the heat generated by the equipment. Software programs. There are many software programs available that can calculate heat load based on input data, such as the size of the space, the number of occupants, and equipment load. These programs use complex algorithms to provide accurate and reliable heat load calculations. One of them is Hvac, Hourly Analysis Program. Rule of thumb. This method involves using general guidelines to estimate the heat load of a space based on factors such as the size of the space, the number of people, and the type of equipment. While this method is not as accurate as manual calculation or software programs, it can provide a rough estimate of the heat load. In order to accurately calculate heat load, it is important to consider all sources of heat generation in the space, including people, lighting, equipment, and solar radiation. The calculations should take into account the specific characteristics of the space, such as its orientation, insulation, and ventilation. By accurately calculating heat load, HVAC systems can be designed and selected to efficiently and effectively remove heat from the space and maintain a comfortable and safe environment.
Why is a compressor used in HVAC? A compressor is a critical component of an HVAC, heating, ventilation, and air conditioning system, as it is responsible for compressing the refrigerant in the system, which is essential for the refrigeration process that produces cooling or heating. In an air conditioning system, the compressor plays the role of compressing the refrigerant gas, which increases its temperature and pressure. The high-pressure, high-temperature refrigerant then flows to the condenser, where it releases heat to the surroundings and condenses into a high-pressure, high-temperature liquid. The liquid refrigerant then passes through an expansion valve, where its pressure is reduced and its temperature drops rapidly, creating a low-pressure, low-temperature liquid refrigerant that enters the evaporator. In the evaporator, the low-pressure, low-temperature refrigerant absorbs heat from the surrounding air, which cools the air and results in a cooling effect. The refrigerant then returns to the compressor to start the process over again. Similarly, in a heating system such as a heat pump, the compressor is responsible for compressing the refrigerant to a high temperature, which allows it to absorb heat from the outside air or ground and transfer it to the indoor air, resulting in heating. Without a compressor, the refrigeration cycle could not occur, and the HVAC system would not be able to provide cooling or heating. Therefore, a compressor is a crucial component of an HVAC system, and it is called the heart FOF air conditioning system. Why capacity of air conditioners is measured in tons? The capacity of air conditioners is traditionally measured in tons, which is a unit of refrigeration capacity. That refers to the amount of heat required to melt 1 ton of ice in 24 hours. The use of the term ton dates back to the early days of air conditioning, when ice was used as a cooling medium in air conditioning systems. The term ton was used to refer to the amount of ice that would be required to provide a certain amount of cooling over a period of time. As air conditioning technology evolved, refrigerants replaced ice as the cooling medium, but the term ton remained in use to describe the cooling capacity of an air conditioner. Day, a ton of refrigeration capacity is defined as 12,000 British thermal units (BTUs) per hour. So, a 2-ton air conditioner can remove 24,000 BTUs of heat per hour from a space. While the use of ton to describe air conditioner capacity may seem outdated, it has become a standard unit of measurement in the industry and is still widely used today. What is HVAC system and what are the types of HVAC systems? HVAC, heating, ventilation, and air conditioning system, refers to the equipment, technology, and processes used to provide heating, cooling, and ventilation to indoor spaces. HVAC systems are designed to maintain a comfortable and healthy indoor environment by controlling temperature, humidity, and air quality. There are several types of HVAC systems, including central HVAC systems. These are the most common type of HVAC system used in residential and commercial buildings. They typically include a central heating and cooling unit, such as a furnace or air conditioner, that is connected to a network of ducts that distribute the conditioned air throughout the building. Heat pump systems. These are similar to central HVAC systems, but use a heat pump to provide both heating and cooling. Heat pumps transfer heat from the outside air or ground to provide heating, and can also be reversed to provide cooling. Ductless mini-split systems. These systems consist of one or more outdoor units connected to indoor air handling units by refrigerant lines, rather than ducts. They are often used in homes or buildings where ductwork is not possible or practical. Packaged HVAC systems. These systems include all components of the HVAC system in a single unit, which can be installed on a roof or ground-level pad. They are often used in commercial buildings or homes where space is limited. Hybrid HVAC systems. These systems combine a heat pump with a backup heating source, such as a gas furnace, to provide efficient heating and cooling. Radiant heating and cooling systems. These systems use pipes or panels installed in the floors, walls, or ceilings to heat or cool a space, using radiant heat transfer. The type of HVAC system selected depends on various factors, including the size and layout of the space, energy efficiency goals, and budget constraints.